we're going to look a little bit more at coordinate proofs, and for this one it says to place an isosceles right triangle in the coordinate plane and then find the length of the hypotenuse and the coordinates of the midpoint. So in order to find, the length of the hypotenuse, we're going to have to use the distance formula, and to find the midpoint m, we're going to have to use the midpoint formula. So placing it in the coordinate plane, again, we want to have at least one corner at 0, 0. And since it's isosceles, we know the distance horizontally is going to be the same as the distance vertically. So we use k to represent that horizontal and vertical distance. To find the length of the hypotenuse, we're going to use these two lengths right here, and we're going to find the distance from P to O. And to do that, again, we use the distance formula. And the two x's, we've got 0 and k. And for the y's, we've got k and 0. If we do that, for the first one, we've got 0 minus k, which is a negative k squared. And for the second one, we've got k minus 0, which is k. So that's k squared. Remember, when we do negative k times negative k, we get k squared plus, plus k squared. We have 2k squareds there, so this is actually 2k squared. And if we take the square root, the k will come out as k, and we'll have the square root left behind for square root of 2. So the length of PO is k rad 2. Now to find the midpoint, to find m, we're going to have to use the midpoint formula. Again, we use the same 2 points. And so the two x's are 0 and k, so we say 0 and k. The two y's are k and 0, so it's k plus 0. 0 plus k is k, so that would be k over 2. And k plus 0 is k, so the second point would also be k over 2. So the coordinate here would be k over 2, comma, k over 2. Alright? And again, they're going to explain that we would put points at 0, 0, k 0, and 0k for these 3 points. We want to have one corner at the origin. We use the distance formula to find PQ. I thought that said PO. Is my eyesight that bad? Oh, it is PQ. I apologize. It is PQ. And so the work is still the same. K minus 0 and 0 minus k. That gives us k squared and negative k squared. And we get 2k squareds there. We take the square root of both sides. We get k rad 2. And again, midpoint formula here. 0 plus k over 2, k plus 0 over 2. Our midpoint is at k over 2, k over 2. And now we want to write a coordinate proof for the mid-segment theorem of one mid-segment rather. So we've got D here and E here. And since we want to just choose a random triangle, we chose a scalene triangle. And if you notice, the letters that they use, they didn't just use P, they use 2p, because we know we're going to need to find midpoints. So if we divide by 2, the 2's will cancel out. And similarly, we've got 2q and 2r. Remember, 2q will be the distance from here to here, and 2r will be the distance from down here all the way up to there. So that's where we get the 2q, 2r. We need to find the midpoint of D and we need to find point D and point E, and we're going to use the midpoint formula to find D and E. Then we're going to look at the slope of DE and compare it to the slope of OC. We're also going to look at the distance from O to C and compare it to the distance from D to E. So we're given that, and we want to prove that it's parallel and that DE is equal to half of OC. So again, we need to prove that these are parallel by looking at the slope. And then once we know what D, the coordinates of D are and the coordinates of E are, we can find the distance from D to E and also the distance from O to C, and show that DE is equal to 1/2 OC. So of course, we found the coordinates for D by doing 2q plus 0 over 2 and 2r plus 0 over 2, because the two x's are here. Whoops, I'm sorry. The two x's are 2q and 0 and 2r and 0. So the coordinates for D are q comma r. And similarly, we would do 2q plus 2p divided by 2 here. And for the y's, it would be 2r plus 0 over 2. We divide this by 2 and we get q plus p comma r. So we have D, which is at qr, and E, which is at q plus p comma r. So to prove they're parallel, we find the slope for D to E, and the slope of DE is a slope of 0 because it's horizontal. OC is on the x-axis, so it's also horizontal. So the slope of that is 0. Therefore, since they both have the same slope, we can say that those two lines are parallel. And for the third step, we want to show DE is equal to 1/2 OC, so we need to find DE and OC. We don't need to use the distance formula, actually, because they're horizontal lines. So if we go back real quick, whoops, we know that D is at QR, and we know that E is at Q plus P comma R. So if we subtract Q plus P minus Q, we get a distance of P there. And if we look at this distance from 0, 0 to 2P comma 0, this distance is 2P, and like I said before, if we do Q plus P minus Q, we get P as our answer. So the distance from D to E is P, the distance from O to C is 2P, so we know in that case that DE is equal to 1/2 OC. Again, QP plus P minus Q is P, OC is 2P minus 0, 2P, and so we know DE is 1/2 the length of OC. We've proven that the mid-segment theorem. Now, in this last example, it says find the coordinates of F, which is the midpoint, and then show that those are parallel as well. So F would be the midpoint down here, and since this is 2P, we can say that F is equal to P comma 0. And we already knew that this was Q plus P comma R. So if we want to find the slope of EF, oops, I'm sorry, we shouldn't say EF, we should say the slope of EF. We take the two y's, which are R and 0, and the two y's, which are Q plus P minus P. So the P's cancel out, we get R over P. Now we want to find the slope of OB. So the slope of OB would be, we have 2R minus 0. So 2R minus 0 goes from here to here, the y's. And then the x's would be 2Q minus 0. So 2Q, whoops, I'm sorry, and this should have been Q here because those would cancel. 2Q minus 0, so we get 2R over 2Q. The 2's cancel here, and again we get R over Q. We notice that the slopes are the same, so that means that those two lines are parallel. Again, R minus 0 is R, Q plus P minus P is Q. 2R over 2Q gives us R over Q. Since they're both RQ, the lines are parallel. And then for this last one, it says to graph these points and find out if it's a right triangle. We want to find the side lengths and the coordinates of the midpoint for all the sides. So here's a sample problem. Again, we could have put this whole side HJ right here, or in this case what they decided to do was make this length M and this length M. Remember, if it's N here, that means this length is different from this length. So we want to know if if it's a right triangle. The way that we know something's a right triangle is by looking at the slopes. For the slopes, we can say that the slope of hj would be a undefined slope because it's a vertical line. We would state that the slope of JO or OJ would be 0, and since these are reciprocals, opposite reciprocals of each other, we know that this is a right angle. Since that's a right angle, we know, yes, it is a right triangle. We want to find the side lengths. We know that from O to J, the length would be M. From H to J, the length would be N, because again, we look at the y coordinates here, we look at the x coordinates here. We use the distance formula to find HO, and I can do the work for that. HO would be M minus O squared plus N minus O squared, and of course that would give me M minus 0 is M, so that would be M squared, and N minus O, or N minus 0 is N, so it would be N squared, so that would be our length. For our third side, we want to find the coordinates of the midpoints. So again, for OJ, it would be M plus, let's see, the OJ, it would be halfway in between these two, so it would be M plus 0 divided by 2, which is M over 2, and 0 plus 0 over 2, which is 0. To find JH, we would do M plus M divided by 2, which would be 2M divided by 2, which would be M. And then we would do N minus 0 divided by 2, which would be N over 2. For HO, we would do M minus 0, or I'm sorry, M plus 0 divided by 2, which is M over 2. And N plus 0 divided by 2, which is N over 2. And so that gives us all our lengths. And that's it for this one. Thank you.